Now we're going to continue our look at average rate of change by actually calculating it, remembering that the formula we used was basically y2 minus y1 over x2 minus x1 to find the rate of change. Okay, so here I have my negative 1, which is going to be x1, and I have 1, which is going to be x2. So the first thing I need to do is calculate my function values, my y values. So I'm going to say f of negative 1. I'm going to plug that in. So 3 times negative 1 minus 2 gives me negative 5. And f of 1 is 3 times 1 minus 2, which gives me 1. So now I have 2 points, and that's really how I want you to think about it. I have negative 1, negative 5, and I have 1, 1. You're going to basically find the slope between those two. So if you think about that, and I'm going to put rate of change is equal to, and I'm going to go ahead and label those, so x1, y1, x2, y2. So 1 minus negative 5 divided by 1 minus negative 1. And I'm going to simplify that, remembering that minus a negative is positive, so I really have 1 plus 5 is 6 over 1 plus 1 is 2, so my average rate of change is 3. Okay, now it's time to realize that you were a little bit tricked. I didn't need to calculate that one because this is a linear function, and for a line, the rate of change is the slope. Rate of change is slope. So if we ask you to calculate the average rate of change for a line, you just have to say, what's the slope? Okay, so do that for the second one, and you can either try it and confirm that you're doing it right, or you can use the rule that we just said, but go ahead, hit pause on me, try it, and then come back. Okay, so when you plugged it in, and you found, if you went ahead and did that, f of 2 is 3 times 2 minus 2, so I have 4, and f of 4 is 3 times 4 minus 2 is 10. So then my rate of change, if I have my points, I forgot to write those, 2, 4, and 4, 10. My rate of change is going to be 10 minus 4 over 4 minus 2. So 6 divided by 2, again, is 3. And that was the same as it was in the first example because our rate of change is constant for lines. I'd like for you to try A on your own and then come back to me and check yourself for this next problem. All right, so let's look at it. So I have f of 0 is 2 to the 0, which is 1. So my point is 0, 1. And then I have f of 2 is 2 to the second power, which is 4. So the point I have is 2, 4. Then my rate of change is going to be 4 minus 1 over 2 minus 0, which is going to give me 3 over 2, and I'm going to leave it like that. Now, do you expect the answer in B to be the same, or do you expect it to be different? The way we're going to want to think about that is, what kind of function do I have? If it's linear, I expect the answers to be the same. If it's any other kind of function, I expect them to be different. Try B and come back to me. All right, so for this one, you're going to see f of 3 is 2 to the third, which is 8, and f of 5 is 2 to the fifth, which is 32. So my points are 3, 8, and 5, 32. Now I'm going to plug in for that rate of change. And I'm going to have 32 minus 8 over 5 minus 3. So I have 24 over 2, which is 12. Okay, so hopefully what you expected is that these answers are different because 2 to the x is not linear. And notice that 12 is much bigger than 3 over 2. And we know from this function, if you think about what this function looks like, it starts pretty and then it swoops up really fast. So when you see that swoop up really fast, that means that the rate of change is greater or steeper as that function continues.